Welcome back, science fans. Imagine a future where the far reaches of the galaxy are within reach. A time when we will be able to travel to planets beyond our solar system. This is the promise of interstellar travel. But how close are we to making this a reality? What new breakthroughs are just around the corner? Let's find out. First, let's see what will power future rockets. One of the most promising approaches is nuclear propulsion. This is where nuclear engines harness the power of the atom to generate thrust. That's different from traditional rockets, which rely on chemical fuels. Nuclear rockets utilize fission or fusion reactions to heat fuel, such as hydrogen, to very high temperatures. This superheated gas is then forced through a nozzle, creating a powerful thrust that pushes the spacecraft to speeds much faster than traditional rockets. Another exciting technology is the laser sail. This propulsion method uses Earth-based lasers to propel a spaceship through space. A project called Breakthrough Starshot plans to use these sails to send a fleet of miniature spacecraft to Alpha Centauri. This is a planetary system 4 light-years away and is our nearest interstellar neighbor. The idea behind this program is to create a nanocraft, a tiny spacecraft weighing just a few grams, and equip it with a light sail, made of super lightweight and reflective material. To propel the craft, a laser stationed on Earth would be aimed at the light sail. The photons from the laser would hit the sail and transfer their momentum to the spacecraft. This continuous push would accelerate it to 20% of the speed of light. At this incredible velocity, the journey to Alpha Centauri, located 4 light-years away, could be completed in only 20 years. Next, we have antimatter engines. These systems were once considered science fiction, but they're now being investigated as a futuristic option in space travel technology. Antimatter engines are based on colliding matter with antimatter. During this reaction, both particles are converted entirely into energy, releasing an enormous amount of power in the process. To put this into perspective, consider the atomic bomb dropped on Hiroshima. The nuclear payload, or the uranium core, weighed around 141 pounds and had an explosive yield of 15 kilotons. In comparison, annihilating just 1 gram of antimatter with 1 gram of matter would release much more energy. This tiny amount of material would unleash nearly 3 times the Hiroshima bomb. If this energy could be harnessed, it could propel a spacecraft to speeds far beyond what is currently possible with chemical rockets or even nuclear propulsion. Theoretically, an antimatter engine could accelerate a spacecraft to speeds up to 70% of the speed of light. This would undoubtedly make interstellar travel a reality. For example, a journey to Proxima Centauri using an antimatter engine could take as little as 6 years. Compare that to over 42 years if you only go at 10% the speed of light. But let's not get ahead of ourselves. Antimatter is very hard to find, and gathering a small amount requires a ton of energy. Once it's created, it has to be stored in special magnetic chambers to prevent it from interacting with regular matter. Unfortunately, we're not even close to doing any of that with our current technology. Imagine saying goodbye to your loved ones as you embark on a journey to the stars, knowing that you may never see them again. Those making this interstellar voyage would be pioneers in every sense of the word. Think about it. Would their descendants remember anything about their home solar system? It's kind of like how some Americans can't relate to their original European heritage. They are long removed from their great-great-great-great-grandparents who first came to the continent. These new astronauts would be leaving behind everything they've ever known. The psychological toll of isolation, along with the knowledge that they may never return to Earth, would test the resolve of the strongest explorers. This is because of the vast distances of space and the limited speeds we can travel through it. Consider the speed of light, which is 186,000 miles a second. At that speed, light will be able to travel roughly 6 trillion miles a year. Now that you understand this, let's again consider our Proxima Centauri example, again only 4 light-years away. The fastest spaceship that we've ever built is the Parker Solar Probe, which travels at 5% the speed of light. That sounds fast, but it would still take 84 years to travel the 4 light-year distance to Proxima Centauri. Even if we could build something faster, say at 10% the speed of light, it would still take over 42 years to travel that distance. Those astronauts would be leaving behind everything and everyone they've ever known. Ultimately, it's a one-way trip. And as they moved farther from Earth, their communications would become numbingly slow. Once they reached Proxima Centauri, a message would take over 4 years to reach Earth and another 4 years for the reply to return to the spacecraft. In effect, the astronauts would be completely isolated, cut off from the rest of humanity in a way that no one has ever experienced before. As these astronauts traverse the vast, empty expanse of interstellar space, they will also be exposed to intense cosmic radiation that could wreak havoc on their bodies. The radiation will damage their DNA and increase the risk of developing cancer. Moreover, the effects of prolonged exposure to microgravity are not to be underestimated. As the spacecraft hurtles through the void, their muscles will begin to atrophy, and their bones will grow weaker with each passing day. However, perhaps the most formidable challenge of all is the psychological impact of being isolated from the rest of humanity for years or even decades on end. In the movies, spaceships are filled with people doing exciting things as they explored the galaxy. The reality is different. The loneliness and unshakable sense of uncertainty that would come in the darkness of space, not knowing what, if anything, awaits them at their journey's end, would be difficult for even the strongest individuals. The psychological stress is almost unfathomable, but in the end, the chance to explore new worlds and to discover alien life is what drives us. As we continue to develop advanced technologies like artificial gravity and faster spaceships, the dream of interstellar travel inches closer to reality. So let us continue to dream big, to reach for the stars, and to never lose sight of the incredible possibilities that lie ahead. The exploration of the cosmos is about understanding our place in the universe, and, as Carl Sagan once said, somewhere, something incredible is waiting to be known. Let us go forth and discover it together. Thanks for watching. If you aren't a subscriber yet, please smash that subscribe button and like the video. Until the next time,